Hey guys, hope you guys are doing well. This is the video to help you get some more points on the probability test. So just if you missed the problem, fix it and then write me a sentence what you did wrong. I need to know what you're doing wrong. Okay, if I can give you that half point back, if you understand what your mistake is, most likely you just made a little error or you double counted something or whatever. But make sure you tell me what you did wrong so I can give you that half point back. All right, so let's take a look. So this was a problem where a lot of you guys, what should I say, that a lot of you guys struggled on. Okay, so it's problem 7 for me, but it's going to be different for you guys because it's all mixed up. So this is problem. It's not really going in order, but I want to do this one first because this is probably the one that most of you lost points on because this is worth 8 points. All right, let's get to it. So Mr. Roden is having a pizza party for his 8th period class. Definitely my favorite class. I like you guys a lot, but 8th period, they're a really special group of kids to me. All right, there are 53 students in the class. He takes a survey of their favorite toppings in the table below. So they're going to have a pizza party, right? All right, so the first thing you want to do is you want to find, and we kind of talked about this in class, we want to find the overlap, all 3 toppings. So that's where you always want to start with a Venn diagram. You want to get the inside out. So we know all 3 toppings, that's going to be 2. So I'm going to put that right there. That's where all 3, watermelon, cucumber, and sushi intersect. So that's going to be 2. Now, only sushi. Now remember, it's only sushi, not anything else. So only sushi is going to be 4. So that's only, and when I say 4, I just mean the sushi part that's not overlapping any of the other ones. Okay? All right. What's the next one? Okay, cucumber and watermelon. So cucumber and watermelon. So when we're talking about cucumber and watermelon, we're talking about this. I don't know if you can see my arrow cursor here, but we're talking about this section right here. Now, cucumber and watermelon is 10, but you already used 2 for the overlapping 8. So, excuse me, for the overlapping of all of them. So you have to subtract off that 2. So that's, if you made that mistake, you got to subtract off the 2. So the cucumber and watermelon, that is going to be 8. All right, now let's do cucumber and sushi. Well, cucumber and sushi is right here. And then again, well, cucumber and sushi has 11. And then you have to subtract off 2. 11 minus 2 is 9. So that's going to be 9 right here. All right, so we've got this one done, this one done, this one done, this one done, right? Cucumber and sushi. So now we're ready to start figuring out the next one. Now I'm going to look at this section right here. This is the overlap sushi watermelon. Now we don't know very much about sushi watermelon, but look what we have here. We have everything filled in for sushi except for this little section right here. Now, we know that sushi total, when you add up all the people who like sushi, there was 24 of them. And we already have this group that we've used already. So if you just take 24 minus 9, so remember 24 is the total sushi, minus 2 and minus 4. So 24 minus 9, then minus 2, then minus 4. You're going to come up with 9. Okay, I'll let you do the math on that. That's going to be 9. All right, so now we have that. So now we can figure out the total cucumber. We can figure out the just cucumber. We can figure out just watermelon. And we can also figure out the nuns over here that you don't like. I can't believe someone would not like at least one of these toppings on their pizza. All right, so how would we do cucumber? Well, we know that the total cucumber is 27. So to find the total cucumber, all we'll do is we'll take 27. We'll subtract off 9 because that's part of the cucumber. 2, that's part of the cucumber. And 8, that's part of the cucumber. We'll just subtract those off. And when we do that, we get 8. All right. And then the last part is total watermelon. Okay. So watermelon. So what's the total watermelon here? Well, let's see. Or just watermelon. My bad. Well, just watermelon. So again, watermelon was 26. And then we'll take off 8 because that was in the watermelon. We'll take off 2 because that was in the watermelon. And then we'll take off 9, and that's in the watermelon. We'll subtract those out. Okay. And we will get 7. That will be 7. All right. Now, how do we figure out the nones? And it's important that you know the nones. Okay, so what you do is you add up all these numbers right here, add them all up, and then we just subtract them from the total, which is 53. So when you add all these numbers up, okay, I'll let you do that because I'm not here to do the arithmetic for you. You guys can add up all these numbers, each little section, add them up, subtract them from 53, and what we get is we get 6 left over. So there's 6 students. I can't believe that 6 students wouldn't like at least one of these toppings or more. Okay, and that's how we would do this one. This was worth 8 points. And what did I grade? Let me just show you where my grades came from on this one. Let me show you my 8 points. 1, 2, 3, 4, 5, 6, 7, 8. That's what I was looking for right there. Those are my 8 points for this problem. And again, this is probably where a lot of you missed some points because this was worth a lot of points. All right, guys, so that's that one. And then let's look at the next one. Okay, so on this one right here, it's question 9 on mine, but you just have to find it. Let me read the question to you. It says, given that a student chose watermelon, what is the probability that he or she chose sushi? So I'm going to pause this because the bell just rang and we're going to have announcements. All right, sorry about that, guys. So, they given that they chose watermelon. Okay, so what I did is I just added up everyone in the watermelon section, 8, 2, 9, and 7. And when I added 8, 2, 9, and 7, I got 26. So your total is only going to be out of 26. And then they're asking, what is the probability that he or she also chose sushi? Well, in the watermelon section, excuse me, how many of them also chose sushi? Well, these 9 chose sushi and these 2 chose sushi. So it's going to be 11 out of 26. And if you take 11 divided by 26 into your calculator, you get approximately 0.42. So 0.42 was the answer I had on that one. All right. So on this one, the question, this is my number 4. I don't know what number this is for you. So on this one, it's saying, what is the probability a student would like watermelon and sushi on his or her pizza? All right. Well, first of all, we're dealing with the entire group of students, Mr. Roden's 8th period. So there's 53 of those because we're not limiting it to anything else besides just the entire group. And the ones that liked sushi and watermelon were this group right here, 9, and this group right here is 2. And so that gives us 9 plus 2 gives me an 11. And if I take 11 and divide that by 53, I come up with about 0.21 when I round to the hundreds place. So about 0.21 on that one. All right, guys, this last one. I don't know what a puular is, but I think we're talking about popular here. Mr. Roden in his spelling error. Sorry about that. I do know how to spell popular. Is it watermelon? No way. Watermelon is not the most popular. Okay, you can just look at it. I believe cucumber, and all you had to do is just look at cucumber because if you look at my screen here, cucumber was 27, sushi was 24, and watermelon was 26. So that was an easy question for you, right? Not a trick question at all. All right, cool. All right, so the next one is, what is the probability that a student will not like sushi, watermelon, or cucumbers on his or her pizza? Well, that means we're just considering the entire 53 students in the class. And how many of them did not like any on their pizza? Well, that's the whole number 6 right here. Okay, so it's going to be 6 out of 53. Surprisingly enough, a lot of you missed this one. Okay, so 6 wanted none. So you had to figure out this none right here. And then 6 divided by 53, If I remember right, that's 0.11, but let me just make sure. So 6 divided by 53 is about 0.11. So 0.11 or 11% of the kids would not want anything on their pizza, right? Which is crazy because who doesn't like some sushi, watermelon, and cucumber on their pizza? Great. All right, so here's my question number 2, and this is this Venn diagram has been given to you. What is the probability that a student liked math or social studies? Okay, so how many students liked math? Well, 5 plus 7 plus 4 plus 3 liked math. So 5 plus 7 plus 4 plus 3 liked math. Okay, now, how many of the students chose math or social studies? Well, how many of those that we counted that were in social studies that were not in math? Because we don't want to double count like the 3 and the 4 right here, because the 3 and the 4 have already been counted in the math. So what part of the social studies has not been counted yet? Well, the 1 has not been counted and the 8 has not been counted. So we want to add up all those, and that's going to be the top of our number. Okay? All right, so what I did the math here, I got 28 total. I added these up and got 28 total, and that's how many students liked math or social studies. That's going to be my numerator of my fraction. Now, my denominator is the total. Now, it looks like all students right here, there wasn't any that didn't like any of them, so they're all included in this Venn diagram here. So, how many were there total? Well, what are we missing here? We're missing these 3 science kids right here who just like science, right? So you add 3 to 28, and you get 31 total. So 28 divided by 31 gives you approximately 0.9. Approximately 0.9, or 90% of the students liked math or social studies. Sorry about that, guys. I just realized I messed up. So I didn't copy and paste, but there were 40 students in the class. So that actually means that 9 students, hard to believe, didn't like any of them. So that was my nuns. So I did have my nuns at 9. Sorry about that. So what we have to do is we have 31, but then we have to add the 31 plus 9, right? So we have to add the 31 plus 9. Or excuse me, the 31 plus the 3 here. So there's 28 students that liked these students right here. Sorry about this mess up here. If I could edit this video, I'd probably do it for you. But all right, anyways, so 28 liked, this is just the math and the social studies, right? And we know that 9, let's see here, the total students. All right, guys, I'm sorry. So, 28 liked math and social studies. Sorry about this. And then there were 40 total kids in the class. So 28 out of the 40 liked math and or social studies. And so that gives us approximately 0.7 or 70%. So that should be your answer for that question right there. Sorry about all this other stuff. It's just it's early in the morning and I'm trying to get this video done, and a lot of things are happening this morning, so I'm getting distracted. So hopefully we'll get this finished up for you. Sorry about that. So we should have 0.7 on that one. Okay, so this next one says, what is the probability that a student answered she or he did not like any of the subjects? Well, that would be the 9 right there, right, guys? So that's the 9 out of, and I believe there are 40 students. So 9 divided by 40 is approximately 0.23 when you round to the nearest hundredth space. All right, so the next one is asking, what is the probability that a student liked math and science? Okay, so math and science. Well, first of all, we're going to consider the 40 kids here. And then we want math and science. Well, where are math and science? It's where the purple and the red intersect. Okay, and means intersection. So that's going to be 7 and 4. So that's going to be 11 out of 40. And 11 divided by 40 gives us approximately 0.23. Excuse me, not 0.23, 0.28. About 28%, 0.28 when you round on that. Okay, so you're going to use the 7 and the 4 is what you want to use because that's the overlapping of the math and the science. Okay, so the next one says, given the probability, given that a student already liked social studies, what is the probability that the student also liked science? Okay, so the first thing you have to do is you're only going to be considering the students who liked social studies. You're not going to be considering anyone else that did not like social studies because that's the key here. So the total is only the sum of the green circle here. So that's going to be the total. So you take 8 plus 3 plus 4 plus 1 and you get 16. Of those 16 students, how many also like science? Well, 4 and 1, 5 of those like science. So 5 over 16 gives you 0.31 when you change it to a decimal. So 0.31 of them, the probability would like that those students also liked science. Okay? All right. Okay, so the next one says, explain the meaning of this symbolic sentence below. Okay, so pretty simple. All you have to remember is this symbol right here. This is the union, which means or. And this is the intersection, which means and. So here's how I would say it. Dogs. This person either likes dogs or they like fish and cats. So this person, you'll make them happy if you get to hang out with dogs, they're happy. Okay. If you want to make this person happy, just give them some dogs. Okay. And they can hang out with the dogs. Or if you give them fish and cats together, not just cats and not just fish, but fish and cats together, then they'll be happy. So this person is happy if they get to hang out with dogs or they get to hang out with fish and cats together. Sound good? So that's what this means. Because remember, this U right here, that's the or, and this upside down U right here, that's the and. So dogs or fish and cats. Okay, so then we have a two-way table here. Sorry for my little typos here, guys. Mr. Roden is 49 years old and was part of the survey. How do you think he voted? Well, pretty simple. You look at, where's Mr. Roden? He's right at the 49, 35 to 49, just at the very tippy top of this. Well, look at what happened. 222 vote in that age voted for it, and only 39 voted against it. So it's most likely that Mr. Roden would have voted in favor of increasing it because it looks like, it's not he could have been one of the 39, but most likely the probability of Mr. Roden voting for it is much greater than the probability of Mr. Roden not voting for it. So I would say he voted for it. So that was a pretty simple question. All right, guys, hope this was helpful. I think I got them all here. I think I checked them all off, that I got all the problems. Sorry about those few little confusions in the middle, but hopefully that helps you. Guys, make corrections. Tell me what you did wrong, and I'll give you half a point for each one you missed. All right, get it in quick because the quarter is coming. The end of the quarter is coming upon us fast. So get them into me quick, and I'll get those points to you. See you later. Bye.